Find the equation of all circles which touch both the axis and the line 3x minus 4y plus 8 equals to 0. So in this question, we have to figure out equations of circles which touch both the axis, the x-axis and the y-axis, and they also touch this line. Pause the video, think about it. Okay, let's do this together. Let's break this question into two parts. Let's first figure out the equations of circles which touch both the axis. For a while, let's forget about this line. Let's visualize circles touching both the axis. So we have these four circles touching the axis, the x and y axis. Pay close attention to how far they are from the origin. Okay, now let's try figuring out equations of these four circles. Let's assume that this distance is equal to a. So this is also a, this is the radius. So if this is a and this is a, the coordinates of this point, which is the center, that's going to be a comma a. So for this circle, which is in the first quadrant, we have the radius and we have the center. So we can figure out the equation. That's x minus a square plus y minus a square equals to a square. That's the equation for this circle. Similarly, we can find the equations for the other three. Pause the video, try it out. Okay. So if this distance is a and this is also a, the coordinates for this point is minus a comma a. The equation becomes x plus a square plus y minus a square equals to a square. The radius is a and the center is minus a comma a. For this one, the center is minus a comma minus a. So the equation becomes x plus a square plus y plus a square equals to a square. And finally, the center for this circle, that's a comma minus a. So the equation becomes x minus a square plus y plus a square equals to a square. So this is how we can figure out equations of circles which touch the coordinate axis. Now here's part 2. We need to figure out equations of those circles that not only touch the axis but also touch this line. So pause the video, try visualizing circles that touch the axis and also touch this line. Try drawing this. Okay. So if you plot the line using this equation, this is what we get. And these are the four circles that touch both the axis and this line. Let's look at the first quadrant. This circle can't be above this line, then it won't be able to touch the x-axis. So it has to be here. It touches the x-axis here and y-axis here and line at this point. Second quadrant is interesting. We have two such circles. One circle is between the axis and this line, and this circle is sitting on top of this line and touching the axis here and here. In the third quadrant, the circle can sit here, and there's nothing in the fourth quadrant. That's because this line does not pass through this quadrant. So if you have a circle that touches both the axis, it won't be able to touch this line. So we have nothing in the fourth quadrant. So this image tells us there are four such circles and we need to figure out equations of all four of them. For this one, for the first quadrant, the equation would look something like this. X minus a square plus y minus a square equals to a square. That's something that we just saw. The equations of the circles in the second quadrant would look something like this. X plus a square plus y minus a square equals to a square. And the equation of the circle in the third quadrant would look something like this. Now, how do we connect the circles with this line? If these circles really touch the given line, then the distance of the center must be equal to the radius. This will help us figure out the missing variable in these equations. What we have to do is, we have to ensure that the distance between the center and this line is equal to the radius of the circle. Let's try this with all of these circles. In the first quadrant, we have a comma a as the center. In the second quadrant, we have minus a comma a. And in the third quadrant, we have minus a comma minus a. Let's try finding the distance of these points from this line. And let's equate those distances to the radius of these circles. So if our circle is in the first quadrant, the distance of this point from this line becomes mod of 3a minus 4a plus 8 divided by root of 3 square plus 4 square. And we equate this with the radius of the circle. So the distance of the point, that's the center from this line, that's equal to the radius of the circle. Let's do this with the other 2 points as well. The distance of minus a comma a, that's our center in the second quadrant from this line, that becomes mod of minus 3a minus 4a plus 8 divided by root 3 square plus 4 square. That's also equal to a. And in the third quadrant, we have minus 3a plus 4a plus 8 mod of this divided by root 3 square plus 4 square. That's equal to a. Now let's simplify these equations to figure out the values of a. In this one, we have 3 minus 4, that's minus a. So that's 8 minus a mod of this equals to This denominator is 5, so that's equal to 5a. This becomes minus 3a minus 4a, that's minus 7a. So that's 8 minus 7a, mod of this equals to 5a. The third one is 4 minus 3 is a, so that's a plus 8 or 8 plus a, mod of this equals to 5a. When we open the mod, we can say that 8 minus a is either equal to 5a or it's equal to minus 5a. So we have two equations from this, 8 minus a equals to 5a or 8 minus a equals to minus 5a. Similarly, here we have 8 minus 7a equals to 5a or 8 minus 7a equals to minus 5a. Here we have 8 plus a equals to 5a and 8 plus a equals to minus 5a. So let's see. Now, two of these 6 equations will not give us circles. We have 4 potential circles. We've seen that in the image. So let's see which of these equations give us values of a that we can use. For the first one, we have 6a equals to 8. That's a equals to 4 by 3. That's positive value of a. The radius can be positive, so this works for us. This next one says 4a equals to minus 8 or a equals to minus 2. This does not work for us. A can't be negative because the radius can't be negative. Let's see the third one. We have 12a equals to 8 or a equals to 2 by 3. This works. Then we have 7 minus 5, that's 2a equals to 8 or a equals to 4. This also works. We can see that in the second quadrant, we have 2 possible circles. Let's see the third quadrant. We have 4a equals to 8 or a equals to 2. And the last equation gives us 6a equals to minus 8 or a equals to minus 4 by 3. This does not work. So we have 1, 2, 3, 4 potential circles. For this one, the equation becomes, if the radius is 4 by 3, the center is 4 by 3 comma 4 by 3. So it becomes x minus 4 by 3 square plus y minus 4 by 3 square equals to 4 by 3 square, that's 16 by 9. Here the equation becomes x plus 2 by 3 squared plus y minus 2 by 3 squared equals to 4 by 9. Here the center is minus 2 by 3 comma 2 by 3. So the equation is x minus minus 2 by 3. So this becomes plus, and y minus 2 by 3. So this stays negative, equals to 4 by 9. This third equation becomes x plus 4 square plus y minus 4 square equals to 4 square, that's 16. And this last equation, this becomes x plus 2 square plus y plus 2 squared equals to 4. Because the center is minus a comma minus a, this means the center is minus 2 comma minus 2. So if it's negative, then x minus minus 2, that becomes positive. Here y minus minus 2 also becomes positive. So these are our 4 equations. Let's put them next to the circles. This is our image. This is the line. These are our 4 possible circles. The equation for this circle is this one. These 2 circles have these 2 equations. And finally, this circle has this equation. So we have figured out equations of all possible circles which touch both the axis and the line 3x minus 4y plus 8 equals to 0.